chapter 17, we're going to move on to our discussions with meteorology and really talk about weather. So to talk about weather, we have to focus on the atmosphere. That's where weather occurs. So the atmosphere is a relatively thin shell of gases surrounding the solid Earth. And the density of the atmosphere decreases as you increase altitude. So as you go further from the surface of the Earth, the density of the gas decreases. It's why it's harder to breathe when you're hiking up in mountains and things like that, because there's just less oxygen around for you to be breathing. So the composition of the atmosphere is important because it sustains life. So about 78% of it's nitrogen, which might be surprising because oxygen is important to us, but nitrogen is important as well. So oxygen only makes up about 21% of the atmosphere, with argon making the other 1%. And then there's a small portion that's all the other gases. And those other components are called trace components because they're present in such a small amount. So water, which is like our clouds, carbon dioxide, neon, helium, krypton, xenon, hydrogen, methane, nitrous oxide, as well as what's called aerosols, which include dust, smoke, salt, and other tiny solid or liquid particles. So sometimes dust and smoke are also called pollutants, and those are aerosols. They're particles that are suspended up in air. So we measure our atmospheric pressure with the barometer. It's a tube that's full of mercury, and it responds to the pressure from the atmosphere. The heavier the pressure on the tube of mercury, the higher the value, which tends to be during weather changes or depending on where you live, based on altitude. Remember, the density of gases decreases as you go up into the mountains. So the structure of our atmosphere is important because they're going to have different properties. So the troposphere is the bottom layer. It's the layer where we live. The surface all the way up to where the temperature stops decreasing with the height. And at that point, you'll see most of our weather occurs in the troposphere. The stratosphere is going to be where as you increase, the temperature is going to then increase as well. And it's less turbulent up in the stratosphere. The ionosphere is above that. It has a temperature decrease and then increase, but what makes the ionosphere unique is that it has merges with the vacuum of space, and the free electrons and ions will reside here. And this is where, like the northern lights, the aureoles borealis, where you can see those, is due to the ions up in the ionosphere getting excited with energy and then dancing around. So wind, we've talked about convection, and wind is convection. We've talked about this several times up to this point, and now we are here to talk about wind. There are three general motions with the wind. The one is going to be the upward movement over a region of greater heating, so hot air rises. Then there's going to be the sinking air over a cooler region because cool air sinks. But then between the cool and the warm regions, we're going to have horizontal motion. And that horizontal motion is what we perceive as wind. So it's the wind we perceive locally, meaning where you are, is because of temperature differences between cooler and warmer environments. So these are called local wind patterns. There are some examples about sea breezes and mountain winds. So when you're at the beach during the day, the breeze seems to come off of the ocean onto land and it's warmer. And at night, the breeze shifts from land out into the ocean and it then becomes cooler. And the direction of the wind is changing for the exact same reason that the local wind is perceived, and that's because of temperature differences between the water and the land. So wind chill is a specific instance of where we have a certain temperature, and because of the wind, it feels like it's cooler than what it really is. So for instance, if we have an outside temperature of, let's say, 20 degrees Fahrenheit, and the wind is blowing approximately 30 miles per hour, you're going to have a perceived temperature of 1 degree Fahrenheit. So that's a big difference. As the strength of the wind increases and the temperature of the atmosphere drops, the wind chill becomes more and more negative, more and more cold. And so you don't need to know the exact numbers of any of these data points or anything about the frostbite. Just know how wind chill contributes to feeling colder, the feels like temperature as the actual, compared to the actual ambient temperature. So global wind patterns are not our local wind. The global wind patterns are going to be because Earth's receiving more direct solar radiation in the equatorial region, meaning around the equator. So if you think about it like a flashlight, if you hold a flashlight straight against the wall and it makes a nice fine circle, you can concentrate most of that light in a small area. But if you start to tilt the flashlight with respect to the wall, you're going to see that the light is going to spread out and reach over a larger area, which basically unequally distributes the amount of sunlight or the amount of light. And that's what contributes to our global wind patterns. Now the jet stream is going to be meandering loops of wind near the top of the troposphere where speeds can be reached up to 100 miles per hour or more. Water is important in the atmosphere. It's a small component. Water vapor is the smallest component of all the water we have, ice and liquid, but it contributes to the greenhouse effect, which is the warming of the atmosphere. It's also one of the principal weathering and erosion agents, and it's also responsible for maintaining life on land. So we're still going to see that water is very important. Here in East Texas, it's very humid during the summer, often early or late spring and early fall, because of the amount of water vapor in the air. And generally, the hotter it gets, the more humid it's going to get because the air can hold more and more water as it gets warmer, which contributes to humidity. So fog and clouds are two types of features that are formed because of water vapor. The difference between fog and a cloud is that fogs originate near the ground, whereas clouds are higher up, but they're both comprised of small suspended water droplets. So they have that in common, but their locations are different. You can see here, this is an image of fog over the San Francisco Bridge, which is not uncommon to see fog over bodies of water because of the cooler nature of that body of water. Fog also typically lifts during the day as the earth warms up, whereas clouds tend to stick around. They don't burn off in the same way that the fog does. So clouds are classified in a number of ways. They're classified based on their shape and in what layer of the atmosphere they form. So cirrus clouds tend to be curly, cumulus piled up, stratus or spread out. The storm cloud that we see, the big thunderheads coming in, is called a cumulonimbus cloud, which is a very tall structure. And we'll see a cumulonimbus cloud when we get to our discussions about thunderstorms. So cloud formation depends specifically on atmospheric stability. If the atmosphere is stable, you're going to have little to no cloud formation. But the more unstable that the atmosphere becomes, the more dramatic and larger the clouds are going to become. So a stable atmosphere is when you have a lifted parcel of air that's cooler and denser than the surrounding air, but the lifted parcel is going to return to its original level because, remember, hot air rises and cool air is going to want to sink. So it's going to basically prevent cloud formation. When we have an unstable atmosphere, the lifted parcel of air is warmer and it's less dense than the surrounding air. And because it's warmer and less dense, it's going to kind of float to the top. It's like holding a beach ball underwater, and after you let go of it, it's going to rise to the top. And that's what this warm, less dense air will do as well. And once it continues to move to the higher level, it'll rise and rise and rise. The more unstable the atmosphere is, the higher the cloud will rise and the larger the thundercloud will be. So rising moist air will cool and eventually reaches the dew point. Droplets condense in the saturated air. The cooling of rising air is slowed and the huge number of droplets appear as clouds. And so that's what causes cloud formation. That rising warmer air eventually starts to cool, condenses just like water condenses on your glass, but they're suspended water vapor molecules that will then clump together to form clouds. So precipitation is the process in which water returns to Earth's surface. Dew and frost are not surface processes, they are surface processes, not precipitation. So because they don't come from the sky above, but they form from the ground, we don't classify dew and frost as precipitation. But rain, hail, snow, sleet, they all count as types of precipitation. So we're going to stop here for chapter 17, and you'll pick up with the last few slides of chapter 17 in the next part.